So we come to question 6, last one in the calculator free, worth 8 marks, and it's really pretty straightforward. There's normally we expect something a bit curly here, but no, we've got a nice little doozy. So here we go. We've got an office here, and the adjacency matrix we're given below it represents the number of doorways between each area, and we're asked to state the meaning of 0 entries that are in here. So for instance, if you look at the B to M, there is no doorway between meeting area M and B. So that's what it's all about. So that's all we've got to say for the first mark. There are no doorways between the indicated areas. For the next part B, let's have a look. Determine the value of X and Y. Here's a copy of the matrix down here. But basically, because this is not a directed adjacency matrix, then we know it's going to be perfectly symmetrical. So we could either say X is going to be, if we follow the diagonal across here, it's going to be 1. And Y, if we come down on the diagonal there, has to be 2. Or you could just work it out and say, right, how many doorways between, so X is between W and K. So W is here and K is there. There's 1 doorway. And then R to W, the resources to workspace, there's 1 door at the right end and 1 door at the left end. So that would be 2. A couple of ways of doing it. Part C, describe how the total number of doorways for each area can be found from the adjacency matrix. So I know when I first looked at this, I thought, how can we work out the total number of doorways? And I missed for each area. But for each area, we simply would add up the numbers in each row or in each column, really. So the number of doorways out of the bathroom, if we add up the numbers in this row, we just get 1. And you can see there it is. There's 1, the total number of doorways. So that's 1 mark there. Over the page, let's head over. Part D is a bit of a mark fest. We're getting 3 marks here for basically completing a network diagram from the adjacency matrix. So what we've got, we were given 4 of the vertices. B was missing, so we'll pop B out there. And then we just have to use half of the adjacency matrix. So B to K, and so we'll add this line in there. And then from where do we need to go next? M doesn't have any connections to the B, K, or M. R to M, so R to M is already in there. And then we're down to the bottom row. So we want a connection from W to K. So that one's missing, so we'll add that line in. From W to M, so that's from W to M, we add that line in. And then we need 2 ways from W to R. One of them was already there, so we just add a second edge there to the graph. And that's the 3 marks. So we keep on moving. Part E. How many different routes are there between the meeting room and the workspace that pass through exactly 2 doorways? So bearing in mind a doorway's an edge, we want to know how to get from M to W along 2 edges. So obviously if we go straight there, that's not going to work because we need a loop to end up back at W. But if we went across to R, that's 1 edge, and then there are 2 ways to get to W. We can go straight up on the one that was given or along the edge that we just added. So 2 routes, and I'm hoping that they don't consider coming backwards as a different route. Otherwise there might be 4. But anyway, there we go, 2 routes. A nice end to the calculator free section.